2.2 point-to-point OSPF networks. And let's begin with 2.2.1. That's the network command syntax. The network command tells the OSPF which interfaces should participate in the OSPF. In the example, you can see router, and in the router config mode, we have a command that's network, followed by network address, wildcard mask, area, and area ID. This is the format, the syntax. For example, you can use the command network followed by such as 10.1.1.0 and 0.0.0.3 and area 0. The router finds interfaces whose IP addresses match the network and enable OSPF on them. Once enabled, the interface can send and receive OSPF packets, find OSPF neighbors, advertise its connected network. Area 0 places the interface in OSPF area 0. 2.2.2 The wildcard mask. A wildcard mask is basically the inverse of a subnet mask. If it's 0, that is must match. For 1, that is ignore. For example, the subnet mask 255.255.255.0 and with a wildcard mask 0.0.0.255. They are inverse to each other. For a /26, the subnet mask is 255.255.255.192, and its wildcard mask is 0.0.0.63. The formula for getting the wildcard mask is using the 255.255.255.255 and subtract the subnet mask. The answer is the wildcard mask. 2.2.4 Configure OSPF using the network command. The network command uses the network address plus the wildcard mask to select interfaces for the OSPF. Here is the sample command, such as in router 1 in the global configuration mode. You enter router and then the key command OSPF 10. Now we enter the router configuration mode. We have 3 examples here. Network 10.10.1.0 followed by 0.0.0.255 for area 0. Also, we can try network 10.1.1.4 followed by 0.0.0.3. This is for area 0 also. And then use network 10.1.1.12, 0.0.0.3 for area 0. Any interface with an IP address in these networks will participate in OSPF area 0. Another method is to use exact interface IP address with wildcard mask 0.0.0.0. For example, we enter the command network 10.1.1.5 and we enter 0.0.0.0 area 0. So here the 0.0.0.0 means every bit must match exactly. So OSPF finds the interface with 10.1.1.5 and enables OSPF on it. Its advantage is no wildcard calculation is needed. 2.2.6 Configure OSPF using the IP OSPF command. You can also configure OSPF directly on the interface instead of using the network command. So the sample command here is in the router interface configuration mode, and then you enter IP OSPF followed by process ID, area, and area ID. For R1, remove the network command by using the no command. And then go to each interface to configure the IP OSPF command as shown in the window here. So first, we are in the global configuration mode for R1. Enter the command router OSPF10. And in the router configuration mode, enter no network 10.10.1.1 and so on. And then the next one, and then the third no network command. After that, now we're going to enter the interface command. For that particular interface, we want to apply OSPF. So the command is interface gigabit Ethernet, such as 0/0/0. In the interface configuration mode, you enter IP OSPF10, area 0. And then the next interface, and then so on. At the end, you enter interface loopback 0, and then IP OSPF10 for area 0. 2.2.8 Passive Interface. OSPF send messages out all OSPF-enabled interfaces by default, even when no OSPF neighbor exists. This can cause wasted bandwidth, which means unnecessary OSPF messages. Wasted resources, that means the device must process the messages. Security risk, that is, the OSPF information may be intercepted. The solution to solve this problem is to configure interfaces without OSPF neighbors as passive interfaces. A passive interface still advertises networking OSPF, but does not send or receive OSPF hello packets or from neighbors. Each OSPF router has a unique router ID, such as for R1, that's 1.1.1.1. R2 in the figure is 2.2.2.2. R3 is 3.3.3.3. The router ID is used to uniquely identify each OSPF router. It is important for following reasons: neighbor relationships, LSAs, LSDB synchronization. 2.2.9 Configure passive interfaces. Use passive interface when an interface has no OSPF neighbor. So the command can be router OSPF10, and then you enter passive interface, loopback 0. This means stop OSPF hello messages on that interface. No OSPF neighbors can form there. The interface network is still advertised to other OSPF routers. The show IP protocols command is then used to verify that the loopback 0 interface is listed as passive. If you look at here, since we use the show IP config command, the passive interface displayed here, the loopback 0 routing information sources, there are two gateways, 3.3.3.3 with distance 110, and then the gateway 2.2.2.2, distance is still 110. So the distance, the default is 110. By default, Cisco routers elect a DR and a BDR on Ethernet interfaces. Even if there is only one other device on the link, you can verify this by using the command show IP OSPF interface, and as shown in the example for gigabit 000 of R1. So in the sample command here, for R1, you enter show IP OSPF interface, gigabit Ethernet 000, and then it shows that OSPF interface information for that interface. The highlighted text shows the OSPF network type, the DR/DBR election result. As shown here, you can see the network type is the broadcast. Ethernet is treated as a multi-access, the broadcast network. So OSPF elects a DR and BDR. The DR, the router ID is 2.2.2.2 with a IP 10.1.1.6. R2 was elected as a designated router. For the BDR, the router ID is 1.1.1.1 with IP 10.1.1.5. R1 was elected the backup designated router. Because both routers have the default priority of 1, the higher router ID wins. The 2.2.2.2 is greater than 1.1.1.1, so router R2 becomes DR, R1 becomes the BDR. The physical link is Ethernet, so OSPF treated as broadcast by default, and elects a DR, also a BDR. But only 2 routers are on this link, so BDR and DR is unnecessary. Change the OSPF network type. So using command interface gigabit Ethernet 0/0/0, and then followed by IP OSPF network point-to-point. Afterward, the network type becomes point-to-point. No DR and BDR election. Routers form adjacency directly. The OSPF neighbor may briefly go down while the network type changes. To verify the point-to-point, you can use the show IP OSPF interface followed by that interface. The output confirms that neighbor count equals to 1, which is the router sees only one OSPF neighbor. Adjacent with neighbor 2.2.2.2, which means R1 has a full adjacency with R2. There is no DR or BDR listed because the interface is not point-to-point. 2.2.12 Loopbacks and point-to-point networks. By default, OSPF idles a loopback as a /32 host route, regardless of its configured subnet mask. For example, a 10.10.1.1/32, but the loopback is being used to simulate the LAN 10.10.1.0/24. To configure it, use the command interface loopback 0, and then enter IP OSPF network point-to-point. Now the OSPF idles the 10.10.1.0/24 instead of 10.10.1.1/32.